Hello everyone, welcome to Singapore Geospatial Week Plus 2020, an event organised by GeoWorks, Singapore Land Authority's Geospatial Industry Centre. Today is our last day of Singapore Geospatial Week, and we're excited to have Yifei from Unity 3D to share on the topic Applications of Gaming Technology in the Geospatial Domain. If you have any questions during the webinar, please leave them in the Q&A chat box and we will answer them at the end of the webinar. Thank you, and without further ado, I will pass the presentation now to Yifei.
Thank you. Okay, let's do this. All right, hope my screen is visible to everyone. So thank you for joining this webinar. I guess some of you are curious why a game engine is participating in a Geospatial Week conference, while some of you are maybe you see the value in real-time technology, and maybe you see the need for real-time technology in visualizing geospatial data. And today's session is mainly to share with you some of these use cases that can be done with Unity, leveraging real-time 3D technology for geospatial data visualization. So my name is Yifei. I'm the lead solutions engineer for South APAC. This covers Southeast Asia, Australia, New Zealand, and India. And also, by the way, sorry for the background noise. I stay in Punggol, so there's constant fighter jets that fly overhead. Hope that's not too distracting. Okay, so a brief introduction about Unity, so that everyone is familiar. So Unity is the world's leading platform for creating and operating interactive real-time 3D. So in the gaming industry, we are very well known, and majority of the games out there, mobile games especially, are made with Unity. So game developers are very familiar with Unity. But outside of games, not so much, because we are fairly new outside of gaming. But there are a lot of applications that uses Unity that you might not have heard of. So using one of the advantage of using real-time 3D technology is you can really improve your iteration speed and visualize your data in real time. And one of the strength of Unity is we support multiple platforms. So to date, we support more than 25 platforms. This includes iOS, Android, Windows, Mac, Linux, VR and AR devices. So this means you have to develop just once, and you can deploy to all these different platforms. So here are some stats. So not surprisingly, Unity is used in majority of the XR applications out there. So take for example, on Oculus Rift, 96% of VR applications are made with Unity. On the Gear VR, that's 87%. On the HTC Vive, that's 74%. And on the HoloLens, that's 91%. Almost all of HoloLens apps are made with Unity. So if you're familiar with games, or you've played mobile games, you may have heard of some of these titles here, like Call of Duty Mobile, Arena of Valor, and Mario Kart Tour. So these are all made with Unity. And if you don't play games, there are some use cases that you may be familiar with too. So for example, Pokemon Go, which is arguably the most popular AR application out there. And then Coca-Cola uses Unity to create their AR campaign to bring a family of polar bear to life. And there's an app, Dr. Seuss ABC, to teach children about alphabets. And this uses Project Mars from Unity. That's a new feature. It knows about, it has context about the environment and automatically places all these different AR objects according to the different surfaces, and then they can interact with each other. So say for example, some AR objects will only appear on a table, and some AR objects will only appear on the floor. For example, like grass, they will automatically appear on the floor versus maybe on the table. So Project Mars is able to let developers leverage on context awareness to easily create this kind of AI application. All right, so that's a very brief introduction to what Unity is and what Unity is able to offer today. So it's not just a game engine anymore, but it's used in a variety of different industry. So today we want to talk to you about how Unity is used in geospatial application and digital twins. So we have a geospatial group, and the mission of the geospatial group is to develop new and innovative workflow to automate the production and streaming of 3D digital doubles of large urban areas. So the team is currently working to integrate with various existing providers and source data in GIS software. And we want to help developers create automated workflows and infrastructure tools and data requirements for custom solutions. So what we do is we help our users capture the real world and then use AI techniques, help them figure out what is in the world, where things are, like buildings, road, trees, bridges, mailboxes, lampposts, for example, and then let them generate new content. If they don't like a specific building, for example, they can offer alternative and let them change the appearance of a building and even change the architecture style. So for example, you can change San Francisco into Paris. So the idea here is automation because cities change all the time. And we need a recipe to automatically update the model. So here is a quick demo to show what the team is working on right now. So what you see here is we are able to ingest here map data, which is a 2D vector map, and then procedurally generate all these 3D buildings on top of the here map. And all the details of these buildings, like the facades and textures, are all automatically procedurally generated. And as I mentioned before, if you don't like the style of the building or shape of the building, you can customize it. So here you see it changes to a Lego style building. Right, so some of these interesting use cases that comes from visualizing a city, for example, could be used in autonomous vehicle training. So there is a use case here where a city is generated from geospatial data, and then because it's generated and it's rendered in real time, we know exactly what these objects are. For example, like we would know this is a vehicle, we would know this is a tree, we would know this is a road, this is a lamppost, and so on. So then we get semantic segmentation, and we can feed these synthetic data into a autonomous vehicle training agent. So here's an example of what you would see. So on the left is the synthetic data or the 3D models that you see, and then on the right, because we know exactly what they are, we can then give context to the training model. So this has a benefit of removing a lot of these, removing a lot of the errors, because if you take real world data, you would have to annotate them And I heard like there are even like sweatshops that will help you annotate these real world footages. And because it's hand annotated, you would get errors, right? You would get human error, and some may be incorrectly annotated, and as a result, your training may not be precise. But what we have here is know exactly what they are, so the data is correct. Here is an example of one of our users that use Unity to create a digital twin of one of their remote, I believe this is a water treatment plant. So here you can see they are ingesting very complex and dense and detailed CAD data of the water treatment plant. So they are able to incorporate sensor data, things like IoT devices, CCTV, maintenance data, geospatial data, and even robotics surveillance to monitor the site in real time. So you don't have to send someone to the site to check up on how the plant is doing, and you can do all this remotely. So I'm going to fast forward this a little bit to just show you some more example of what they can do here. So here, for example, you can get CCTV footage of the actual thing there. And here, for example, maybe somewhere here. Oh, too fast. Here, yeah, just slightly. Here, you can even get like a point cloud data of the actual site. If I can scrub to the right. Nope. Okay. Yeah, you can even visualize point cloud data of the actual site. So you can visualize the actual site in 3D. So another very interesting use case is this is a project that our finger food group or team has worked on. So we recently acquired finger foods. And they are now part of our professional services team that can offer custom solutions to our customer. So before joining Unity, they worked on various amount of industrial use cases, and Ambridge is one of them. And this is an interesting one because it allows the user to visualize geospatial data in a very intuitive way. So what we have here is a underground pipe, and they would need to check and monitor the pipe for deviation. If there's at least a 2% deviation, they will need to report it because they need to maintain the pipe integrity and make sure that nothing goes wrong. So the way they collect the data is they place a lot of sensor in the site, and all these data are collated into a 2D spreadsheet. And with the 2D spreadsheet, it's hard to visualize like on the pipe where you would see areas that might have deviation, and you would need to have someone look at it. But what they did is they take all this data and put it to visualize in a 3D way. And here you can see the person wearing a HoloLens, and you can see the pipe with different color to indicate the severity of the derivation. So you can just focus on areas that are more purplish. So then you can have at one glance know exactly where on the pipe you need to focus on. So this is a lot more intuitive and easier to view the data than just on a 2D spreadsheet. They can also visualize the area to know why the pipe was that section of the pipe was maybe have a high maintenance cost, and why the deviation happened. Maybe because of the terrain slope or some movement in the earth that causes that. So they can get historic data on the terrain to see how the earth shift, and then the slope that may affect the pipe integrity. So here's a small video to show you how this thing works. And this is another project that the finger food team has worked on, and this is also an interesting one. This is Ore Vision. It's a project that is still in development, but what you see here is the Red Lake mining area. So they are mining for gold in this area. What they do is they use diamond drills to drill tunnels into the ground. And as they drill, they collect core samples. And from the core samples, they can analyze and know the composition of the earth, right? And as they drill more and more tunnels, and if I remember correctly, in this case, they have like over 100 tunnels. As they drill more and more tunnels, you collect more samples along the tunnel, and using Unity, you can have a color to the different composition along the tunnel. So then with over hundreds of tunnels, you can start to see where some of these minerals are deposited in, and you can get an idea of where you should drill next. So in this case, because they are hunting for gold, that's what they're interested in, to see which area of the earth would have a higher composition of gold, and they should then start drilling in that direction. So this is also the same example of how using a 3D real-time 3D technology can help with visualizing the data, because again, data collected will be in a 2D form, and analyzing this data will take a lot of time, and it's not very easy to visualize where exactly they should drill. But through 3D, you have a very intuitive and fast way to quickly visualize and get an idea of where they should focus on in the drilling effort. So Unity also plays a very active role in ingesting real-time BIM or building information modeling data. And we have a product called Unity Reflect that makes this easy. So what it does is it's a real-time BIM viewer that you can ingest data from different BIM software, for example, Revit, Rhino, SketchUp, and then visualize them in one viewer. So you can visualize them in AR, in VR, on a mobile device, on a PC, and it's real time, and it's as a live sync with the source material. So any changes, for example, that you made on Revit is instantly reflected on the Reflect viewer. So here's a quick video to show you how this works. So with Reflect, you can start to do very interesting stuff with your geospatial data. So for example, you can then start to visualize how, for example, your building would look like in the surrounding environment. And you can also do sun study. For example, here you can see how the light will affect your building and the surrounding buildings. Here's another example of the sun study feature running in Unity. So it's just not about visualizing in a 2D screen. You can also visualize in VR. So the same sun study that you saw running in Reflect, this is in VR. So you can be immersed in the actual environment and then see how the sun or the light will look like at different time of day, different time of year. And that's it. Thank you very much for your attention. And if you have more questions, if we can't answer today in the Q&A session, you can always reach out to us. My email is yife@unity3d.com, and my colleague's email is there as well, stan.dekaiser@unity3d.com.
Hi, thanks Ife for your presentation. So now we'll move on to the Q&A segment. So I think we have two questions currently. Let's start off perhaps with the first question.
Sure.
What type of cloud technology or software are you using to process, render, and analyze 3D dataset?
What type of cloud technology or software are you using to process, render, analyze 3D data set? Could you elaborate what kind of 3D data set are you referring to?
Perhaps TH, you could comment inside the question box.
So, but maybe I'll just try to answer the question as, okay, TH says 3D size is huge. What do you use to reduce the lagging effect, the process and enable sharing of 3D data sets? Right, so yeah, 3D data set is huge, and that is a challenge. So we have done a lot of optimization in how we ingest 3D data. Take for example, like what you saw in the 3 kilometer by 3 kilometer San Francisco map. So data is streamed in instead of everything is loaded into memory. So it's gradually streamed in as needed. So that can keep memory usage low. So we have also a cloud service called Furious, which is a render streaming, which uses render streaming technology. So what this means is the processing is actually running on a cloud server on a powerful machine, and the result is streamed to the user's device, whether it's on a mobile phone or it's on a PC screen or whatever, as a video stream. But you can still interact with the application on your device. So you're sending back your input back to the cloud server to interact with the application. So if you're familiar with games, this is similar to what Google Stadia is trying to do. If you're not, then this is similar to TeamViewer. So you're logging into somebody else's machine. The actual application is not running on your machine, it's running on somewhere else. In this case, it's on a cloud server. Your machine is just a terminal that you interact with the application. So that's another example. Otherwise, we have the question disappeared on the thing.
Oh, it's under the answered tab.
Okay, I hope that answered your question. Otherwise, feel free to send us an email. We can follow up with you. Right. Next one. Does Unity Reflect work with HoloLens 2? HoloLens 2. So theoretically, yes. So Reflect basically is a viewer that is an executable that works out of the box, but it comes with the source code as well, which is the Unity Reflect project that you can open up in Unity Pro, and you can make modifications or customization to it. So the viewer itself right now runs on iOS, Android, supports Oculus, and with Vive support coming soon. But that's out of the box viewer, the executable. If you have the source code, you can add in any of the platforms that Unity supports right now. So that means HoloLens 2 as well. Right. Next one is Unity able to handle extremely large 3D cities with lots of polygons and texture? How does its performance compare to Unreal Engine for such large scene? So as you saw in the demo video earlier, in the San Francisco demo, so right now the geospatial team is working on streaming in large urban size map. So I don't have the numbers, but I think they did a larger one at 5 kilometer by 5 kilometer. the one that you saw on the video is a 3 kilometer by 3 kilometer. There, I don't exactly have the numbers for how large we can support, but what's the polygons and texture, but a lot of it depends on the complexity. We do have a virtual texture streaming technology, which means you can stream in texture as needed. So you're not streaming in or you're not loading in all the texture at once. It's a virtual texturing technique if you're familiar. So we're just streaming in textures that you can see. So we can keep the memory usage low. And as for the polygons, again, I don't have the numbers, but it's similar to what you saw. It's again, it's just streaming in data, so we're not loading in everything at once.
And I think the next question is the Geospatial Group based in SG?
Unfortunately, no. The Geospatial Group is not based in Singapore. It's based in, I don't remember which country, but it's in a Western country.
And the next question is, you showed the procedural generation of buildings using City Engine. Is that part of Unity?
So City Engine is not part of Unity. City Engine is part of Esri, if I'm not wrong. And we're currently working on a lot of these different GIS data providers. Esri is one of them, to try to integrate with Unity. So what you saw there is an example of how we integrate with City Engine to generate the data. So if I'm not wrong, Esri currently already has a plugin for Unity. It's in beta. I hope that answers the question. Next one, any new developer resource to create mixed reality app, not game? New developer resource. So there's this Learn site from Unity that covers a wide number of topics. Again, it's not just for games. There's a lot of topics here that focus specifically on mixed reality, for example. There are topics that also focuses on Reflect, for example. So currently, all content on the Learn site is free. If I remember the website correctly, it's learn.unity.com. Let me check. It's learn.unity.com. Yeah, that's correct.
And I think there's a question on, is Unity 3D more than an engine? But is it also a move into software and even turnkey solution and partner collaborations like Autodesk?
Yeah, so Unity 3D is not just an engine anymore. Our business model is a software as a service. So we're not just providing the engine, we're also providing services. Some of the services would be like cloud build, for example. So you can have your projects built on our cloud server and then give you back the different builds, maybe one targeting iOS, one for Android, one for PC, and so on. We have also Unity simulation services, which allows you to run your simulation, your parameterized simulation at scale. So you can run multiple instances of Unity on the cloud server at different parameters and then get your simulated result fast. The simulated result back fast. We have also a very tight partnership with Autodesk. So for example, we are the only one with the source code to the FBX file format. So we know exactly how to ingest the data, how to export the FBX data. Yeah, and we have a professional services team that can also build custom solutions for customers that want it.
And I think perhaps we have time for one last question. So how can we use Unity's city procedural generation features?
Right, so this is currently still in development. It's not available yet, but we will definitely share more when the Geospatial team is ready to make more announcement. But what you saw is an early preview, a peek into what the team is doing right now.
Okay, I think we have come to the end of the webinar. So thank you so much, Ife, for sharing with us all your insights about Unity 3D and the applications. Thank you, attendees, for all the engaging questions as well. So for those who have more questions, you can email Ife directly at his email to reach out to him. And right now, we would like to thank everybody for attending today's webinar. And do follow us on our social media pages and conversations using the hashtag SGGeoWeek. We also have upcoming webinars by TomTom and AWS Next. We will put the link in the chat box below. Thank you so much, and we hope to see everyone again.
Thank you,
Thank you.
everyone.
Bye-bye.
Bye-bye.